Okay. Once I start multiplying and dividing with sig figs, the answer to a multiplication and division problem should have as many figures as the one with the least significant digits. So that means if I take 1.2 grams and I multiply it by, instead of multiplying, let's say we're dividing. Let's say I divide it by 0.680 milliliters. Your answer can only have as many sig figs as the term with the fewest. 1.2 has got 2 significant figures. 0.680 has got 3 significant figures. The fewest would be 2. So that's why your answer is allowed to have 2 significant figures. Okay? So this is going to be 1.2 divided by 0.680, which is 1.764. I'm going to underline the 1.7. I would need to round this to 1.8, and the unit is grams per mil. That's 2 sig figs. That's the rule that you apply every single time you multiply and divide. Okay? So let's take a look at the next page. Let's look at the quick check. You tell me, for number 1, how many significant digits do I have in 0.14? 2. So I'm going to underline them. Okay. And then for the next one, 14.00, how many sig figs? 4, because the trailing zeros count because there's a decimal somewhere. So that means in my answer, I would need to have 2 significant figures. Okay. So you're going to take 0.14 times 14. You're going to get 1.96. What would this be if I wanted it as 2 sig figs? 2.0, and then my unit would be meters squared. Okay. For number 2, how many sig figs are in 940? 2. How many are in 0.850? 3, exactly, because the trailing zero counts because there's a decimal somewhere. So that means I want to have 2 significant figures in my answer. So 940 divided by 0.850 is going to be 1105. I'm going to underline the 11. You can't drop the 0 and the 5 off and just say that 11 is the answer. Okay, because quantity-wise, it's nowhere near the same as 1105. Does that make sense? So what you would do is, since you have a 0 after the 1, this would become 1100. You round it down to 1100 to give you 2 sig figs because that quantity is around where I need it to be. And then your unit is grams per mil. Okay, number 3. How many significant figures are in 0.054? 2. Leading zeros are not significant, even if they're after that decimal right there. Okay. 1.101, how many sig figs? 3. Okay, so I'm going to underline all of them. I want 2 sig figs in my answer. So you're going to take 0.054 divided by 1.10. I get 0.04909. I'm going to underline the 4 and the 9. After the 9 is a 0, so would I round it up? No. So this would be 0.049, and your units are grams per second. That's 2 significant figures. We understand? Okay. I'm telling you now, do not start practicing this on Sunday night. You're going to forget what we did. Even though I have the lecture videos posted, start practicing it a little bit every day. Even if you just do 5 a day, you need to start putting this into your long-term memory, and you can't put it into your long-term memory if you cram. Okay? So you have a worksheet on multiplying and dividing. There's 20 practice problems, and then you have the key on the next page, and I actually show you, I underline sig figs as I go along. Okay? All right. We cool with this? All right, let's take a look at adding and subtracting. We're leaving the rule for multiplication and division, and I'm going to adding and subtracting. This is a completely different rule. So anytime that you are adding and subtracting with significant figures, what you want to do is you want to line up the decimal and draw a line after the last place. So the number of sig figs in your answer is determined by the place value of the last significant figure in each number. So what that means is you're going to round to the smallest number of decimal places. Now, I have students every year try to do this in their head. It doesn't work. You want to put it on paper and take a look at it. So let's take a look at the next page. We're going to look at these 3 practice problems. Okay. I'm going to show you what I would do if I was doing this myself. So for number 1, I have 16.407 plus 5.70. Notice I'm lining up my decimals. Then you're going to draw a line after the term that has the fewest decimal places. Doesn't the 5.70 have the fewest because it only goes to the hundredths? So you would draw a line here. Okay? Don't do any math like longhand. Put it into your calculator. Write out what your calculator gives you, because I see too many students making mistakes when they do it the longhand way. Underline the digits to the left of the line. These are the digits that you're allowed to have in your answer, and we only round if after the line is a 5 or greater. So since that's a 7, the 0 rounds up. 22.11 would be my answer, okay? So my unit is milliliters, so this would be 22.11 milliliters. Okay, let's go to number 2. For number 2, I have 0.32 and 0.009. I'm adding again. Where should I draw my line? After the 2? Yeah, here. Okay, so you will get 0.329. Underline the digits to the left of the line. If after the line is a 5 or greater, you will round up. So that means we will end up getting 0.33. And my unit is grams. Okay, number 3. Last one. This one's a little bit trickier. I have 750 plus 8.001. Technically, 750 is only significant up to the 5 because I don't have a decimal written. Does that make sense? So technically, you would be drawing your line here. Okay, so 758.001, I would underline the 7 and the 5 because that's the significant digits that I'm allowed to have in my answer. But since after the line is an 8, the 5 will round up to a 6. Be careful. Don't round off your answer to 76 and think that you're done. Quantity-wise, 76 is nowhere near 758. So you need to put a 0 on the end to keep the quantity relatively the same. Do not write a decimal because then that would make that trailing 0 count. So my answer would be 760 meters. Okay? Yes? Okay, you have an entire worksheet on this as well. Okay, you've got an addition and subtraction, 20 problems, and then on the key, I showed you which place you were supposed to draw the line after. Okay? Okay. Any questions on this before I go on? Okay. So I have a couple of things to talk about and then we're done. Let's go over here. We need to talk about exact numbers, and I need to bring together multiplication, division, addition, and subtraction into the same problem, okay? So what I'm going to do is I'm going to write the rules for exact numbers here and do this quick check with you, and then I'll give you class time to practice those problems, okay? All right, so exact numbers. Exact numbers contain infinite significant figures. So that means when you use them in a calculation, they don't affect the sig figs in your answer. And this will become really relevant when we get to the last section of the chapter. Exact numbers come from a few places. These are defined quantities in the same measurement system. What that means is 1 centimeter equals 10 to the negative 2 meters would be an example. Centimeters and meters are both in the metric system. The number 1 and the power of 10 would be exact. Therefore, they would have infinite sig figs, and you can't consider them when determining sig figs in an answer. Another example would be, in 1 foot, I have 12 inches. Feet and inches are in the English system of measurement. So since I'm in the same system of measurement, the number 1 and the number 12 would be exact, okay? There are also some common things that we use every day. We know that in a minute, there are 60 seconds, or in a day, there are 24 hours. So these are some defined quantities that also are exact numbers that we use every day, okay? Also, they come from counting objects. So if you can actually count objects, like if I had 13 chocolate chip cookies and I physically could count them, the number 13 would be considered exact, and it would have infinite sig figs. Okay? Now, when you're performing problems and you have a number in an equation, like the 100% in percent error. When you have a number in an equation before your data is put in it, that number in the equation is exact. So the 100% in percent error is exact. Let me give you an example. Up here, this 100% is part of a percent error equation. This is a percent error calculation. I know that just by looking at it and the format, okay? So that means that the 100% has infinite significant figures. So I don't consider how many sig figs it may have when I perform the calculation. Does that make sense? Okay, another example would be if you were taking the average of 3 numbers and you divided by 3, the number 3 would be an exact number. You wouldn't take that into account when you calculate sig figs. Does this make sense? Okay, so the number 1 in conversions, always exact. The quantities that are in the same system of measurement, those conversions, always exact. And then these common everyday quantities like the 60 seconds in a minute and 24 hours in a day, 60 minutes in an hour, those are all exact numbers as well. Are we good with this? Okay, so the last thing I need to talk about with you is performing these multi-step calculations. Okay, so I'm gonna get rid of this and I'm gonna record the last video. Do we all have this down? That says in percent error. Okay.